Hey, what's going on, y'all? Sean, owner and lead tutor of Math Swap Tutoring, and today I want to talk about finding the derivative of exponential functions. Remember, if you're looking for tutoring, look at the bottom of this video. You'll see the link to to schedule a free consultation. You also see the link to join my weekly SAT, ACT math practice class. And also don't forget to subscribe to this YouTube channel and like and share this video. I do post regularly. So anyway, here we go. So first of all, when I talk about an exponential function, I'm talking about a function that uses Euler's number, or which can be also incorrectly referred to as Euler's number, the way it's spelled. Um, but anyway, it's that number e, or constant rather, to the x power. All right, so if we're talking about finding the derivative of this, generally, actually, I need to add something to it. The general way to find the derivative of an exponential function is the derivative is a times e to the ax. So basically what happens is when you take the derivative, the constant in front of the x term comes out front, and then the rest of the exponential stays the same. It's really like the chain rule if you look at it. So it's like the outside stays the same, and then you multiply it times the derivative of the exponent, if you see, because so you keep the e to the ax, and then you take the derivative of the ax term, and then you get ae to the ax. So it's really like the chain rule at play. Okay. All right. So basically, when we talk about the most basic exponential function, the derivative of e to the x, you can already see that just be e to the x. Okay. Because the constant in front of the x term is just one. So that comes out front in theory, but you just have e to the x there. So anyway, that's just a quick something like if you see that in the problem, you already know that the derivative of the exponential function e to the x is just e to the x. All right, so there's not that much to this. So let's just do a few examples and then I'll have you on your way. So let's take the derivative of 3e to the x squared. Keep in mind, if you want copies of these notes, you can go to my website and subscribe, Math Swap tutoring.com/subscribe. And then you'll get a link to where my downloadable math notes are that I use to record these videos before I record them. And you can just take them out, hole punch them, put them in your notebook, refer back to them, that type of thing, okay? All right, so let's take the derivative of this. So like I said, this is the way in general that you find the derivative of an exponential function. But keep in mind that this is like essentially the chain rule. And you're going to more directly have to apply a chain rule here. So notice that there is no constant here, but again, we're going to apply the chain rule. So basically the way this is going to go is it's going to be the derivative of the outside, which is just 3e to the x squared, times the derivative of this x term, which is going to be 2x. So this is going to be 6x e to the x squared, okay? All right, so let's keep on going. Let's do another example. The derivative with respect to x of 4e to the x squared minus 6e to the 4x plus 9. All right, so that means we're going to take the derivative of each separate term. So that's going to be the derivative of this one is going to be, again, let's apply chain rule. So that's 4e to the x squared times 2x. Okay, minus the derivative of this, minus 6e to the 4x times 4, applying that there. And then the derivative of this term right here, 9, remember the derivative of a constant, is just 0. All right. So that's going to be, let's combine everything. So that's going to be 8x times e to the x squared minus 24 e to the 4x. Okay. Just combining all that stuff together. Be careful with all your terms, combine everything correctly. Watch out for your exponents and negative signs and all that kind of good stuff. All right, let's do one more, a little bit more involved example, just to kind of exercise that calculus math muscle. All right, so let's do the derivative with respect to x of 2 plus e to the minus 2x over e to the 3x. So if you look at this here, you could do this two different ways. You could apply what probably might be initially more obvious, which is the quotient rule, because you have a function divided by a function. Or you could apply the product rule if you remember how exponent rules work. And what I mean is whenever you have, so just keep in mind, looking at this term right here, e to the 3x, remember e to the 3x is the same as, let me put it this way. I mean to say 1 over e to the 3x, which is essentially what we have here, is the same thing as e to the minus 3x, with e to the minus 3x being in the numerator this time. Okay. All right. So let's do it with, let's just do it with both, man. You know, it doesn't hurt to kind of do both, because it helps to prove also that you can, it doesn't matter, you'll get the same answer. So let's do the product rule here first. So remember so first we're going to rewrite this as the derivative of e to the minus 3x times 2 plus e to the minus 2x. Okay, so now let's go ahead and apply the product rule. I'm going to write product rule here. Product rule. All right. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. So that's the first times the derivative of the second. That derivative is 0. This derivative is going to be negative 2 e to the negative 2x plus the second times the derivative of the first. And the derivative of the first is going to be negative 3 e to the minus 3x. All right, combine everything. So when you combine this, make sure you pay attention so you have a negative 2 times e. You got these two e terms, e to a power, the same base, and then that means that you add the exponents. So it's going to be negative 3x plus negative 2x, which is a negative 5x, plus, let's combine these. Remember, this is going to be distributed to the 2 and this term right here, e to the minus 2x. So it's going to be, first I'm going to do this in parentheses. So it's going to be negative 6 e to the minus 3x, combine these two now, minus 3 times e. Now we're combining these e terms here. So that's going to be negative 2x plus negative 3x, e to the negative 5x. Okay. All right. So now I'm going to go ahead and combine these and get the final answer. So that's going to be negative 2e to the minus 5x minus 3e to the minus 5x. So it's going to be minus 5e to the minus 5x minus 6e to the 3x. All right. So now I am going to solve this using the quotient rule. So here's the original problem. All right, here we go. It's kind of fun stuff, man. All right. So remember, the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So it's equal to the bottom times the derivative of the top, derivative of 2 is 0, derivative of this is going to be negative 2e to the minus 2x minus the top times the derivative of the bottom, that's going to be 3e, 3x, 3 times e to the 3x, all over the bottom squared. So that's e to the 3x quantity squared, which is just going to be e to the 6x. 3, yeah, right. There's e to the 3x times e to the 3x, and that's going to be add the exponent. Yeah. All right, so here we go. So now let's combine. So a lot of stuff going on here, but we can just take our time and work it out. So it's going to be negative 2 times e to the 3x minus 2x. Negative 2 times e to the x. Okay. Okay, now let's be careful. I'm not going to put this negative in there right now. Let me see, that's going to be minus. This term times 2 is going to be 6e to the 3x plus these times each other is going to be 3e to the x all over e to the 6x. Okay, it's taking our time here. Let's keep on going. So I'm just going to distribute this negative now. It's going to be 2e to the x minus 6e to the 3x. Oops, messed up there. Oops. Minus 3ex. So if you look here, you have, oh, see, I almost messed up. I almost forgot to bring that negative here. And then everything's over e to the 6x. Now, if you look here, you can combine this term and this term. These are going to be negative 5e. So let's rewrite that here. So let me draw an arrow so you can see exactly where I'm going. I'm going to bring this over here. All right, so that's going to be equal to negative 5e to the x minus 6e to the 3x over e to the 6x. All right, so let's rewrite this so we can see how we can kind of combine these a bit. So that's going to be negative 5e to the x over e to the 6x minus 6e to the 3x over e to the 6x. Now, if you look here, we can do some exponent division, which means if you have these numbers raised to a power with the same base, you can subtract the exponents if they're being divided. So x minus 6x is going to be negative 5x, so it's going to be negative 5e to the minus 5x minus, when you subtract these, that's going to be 6e to the negative 3x. If you look at this answer here, and you look at the answer here up top, these are the same. Okay, so two ways to go about the same thing. It looks like the product rule is end up being a little easier to like get to the answer. But yeah, whichever works best for you, whichever you notice, that's really all that works. Make sure you follow, because I do post videos regularly. Share with your friends. Do great in calculus and have a good one.